Welcome to the end of the beginning, let's say, in this list of Introduction to GIS lectures and components. GIS learning never ends, of course. Even after you take a course or watch a video, you eventually move on to the next one and the next one and the next one. But at some point, a course has to end. A season of videos or lectures has to end. And I don't expect this to be, frankly, even the last video in this playlist, but we have to start finishing at some point. And so here we are. GIS is something that continues and continues. And for those who have been in a course with me or who have been watching along on the video sets, we've covered a lot of ground and we've covered a lot of components. And where we've been and where we'll go are both important points along the road of where we are. And where we are has been learning GIS. One of the things I say at the beginning of any GIS course is that you will be overwhelmed. This is not to weed people out or scare anybody, anything like that. I don't believe in weed outs or stuff like that. GIS is for everyone. GIS will always be for everyone, but the realities of what GIS is are important to recognize. It is not a walk in the park every day, every time you load up ARC. There are challenges, there are frustrations. You wonder why you're getting an error. Doing something you've done 100 times, and then it stops working. Or maybe worse, maybe something isn't working 99 times and you're frustrated and overloaded and you can't figure it out. Then you find the missing file path or the missing setting in the tool or the missing data. And then it works once, 99 failures, one success, and you move on to the next thing that fails 99 times and succeeds once. So GIS can be overwhelming. And I think that no matter what level of practice you are doing or where you are with GIS, that's true. But one of the things that makes GIS so great is that it's a way of thinking. I strongly believe in a multidimensional conceptualization of what GIS is, geographic information science systems, whatever you think. But the science part of GIS is very strong. And as you're doing GIS within the software, within reading or listening or learning, however you're doing it, you are addressing problems in new ways. You are learning how to take a problem or take an issue or take a topic and handle it differently. Throughout our GIS explorations, and until we can figure out a way to replicate this universe perfectly, to simulate where we are, we have to handle and grapple with the fact that GIS is an abstraction. And that abstract nature of GIS then leads to other things we have to think about and other pieces we have to confront. We are doing our best to understand the relationships between things on this planet in an abstracted digital format. And through doing that, we have to return to the real world with our findings and make decisions. We have to figure out how to bring data together across different formats. We have to consider what those formats are and how they operate. We have to deeply consider. We have to deeply seek out means of translating our three-dimensional space to two-dimensional space. But is this not a lesson on GIS in its own? That everything is a representation and that we have to take as best we can our decisions and turn them into best practices, best fits, things that preserve what we need to preserve and distort what can be distorted. Your brain on geography, as it were. We grapple with associated domains like math and stats and computer science and environmental science and sociology and geography, of course. This works us towards the idea of inquiry. That doing GIS and working within GIS is a process, not just a workflow, not just a data flow, but a process of asking geographic questions, acquiring geographic resources, exploring geographic data, analyzing geographic information, and then acting on geographic knowledge. GIS enables and creates a platform for us to do that. But we don't have to have GIS. One of the pieces that is important to take away from a GIS course, and it's perhaps a bit counterintuitive, but it's that you don't need GIS to succeed with the things you learn in a GIS course. And in fact, the pieces and the components that you learn within GIS, the buffers, the database joins, the analytical flow, are just as relevant in hundreds of other applications and places. Take Eratosthenes, for example. Certainly a multifaceted jack of all trades, often regarded as the first geographer, who simply noticed in his home in Alexandria, and when he visited Syene, that on the summer solstice, the sun's rays cast a shadow differently in those two places. And that at Syene, there was no shadow at the bottom of the well he was looking down. And then in later years, when he was in Alexandria, there was a shadow on that solstice. Eratosthenes being a geographer and mathematician and many other things, of course, a librarian among them, well-learned, said to himself, well, if I can measure that angle in Alexandria, and I know the sun is overhead at Syene, if I were to know the distance between those two locations, I could probably calculate the size of the Earth. And so Eratosthenes got to his mathematics and hired someone to pace that distance from Alexandria to Syene. Imagine walking across the North African desert. I assume a camel's involved. Getting a distance of 5,000 stadia, doing the math, calculating it out. And Eratosthenes came to a calculation of 252,000 stadia. It's the circumference of the Earth. And he was only off by 1.5%. With wells and observations and pacing, he was by far the closest of any pre-20th century, 19th century maybe. Anyone before that time. Eratosthenes got the closest. He observed, he thought, he applied himself across many different domains, hired someone to pace it, and he only missed, really, because the Greeks pretty much thought that everything was a perfect sphere. which we know it isn't. All of these things work together: computational thinking, spatial thinking, problem solving. And GIS enables them all. GIS enables everything. So it is true that GIS is for everyone, and that in learning GIS, you are being enabled everywhere. It does not require just GIS software. It does not require just a certain type of GIS software. It is applicable over many different places of doing GIS, many different functions, many different components. In this set of videos and the walkthroughs that I do, I use ArcGIS, ArcGIS Pro. It's what I'm familiar with. It's what I'm comfortable with. But there's plenty of other GIS programs out there. In fact, many of them are open source programs. This connection between open source or closed source software, between Creative Commons sharing of learning materials like these are, our proprietary ones, between buying a textbook or downloading some labs and watching some random YouTube videos on the internet. Hi, everyone. It's certainly a deeper discussion that we could dig into. One thing I like to highlight in thinking about and doing GIS is whatever tool works is the best tool for you. Sometimes open source works. Sometimes you have a problem that's never been seen before and will never get fixed or understood. Sometimes you need some assistance from someone who has expertise on a certain platform, someone who is technically trained. Sometimes you can't afford to download the fancy corporate software. And while Esri products are certainly a monolith in GIS, about half of all GIS is done within various Esri things. There might be times where you don't have the funds, where you don't have the access, where you don't have the licenses to be able to use it. Now, guess what? One of the things that's important to note in learning GIS, doing GIS, working with GIS components, is that all of the ways of thinking, all of these components of understanding how a tool works, how a workflow happens, the nature of what a database join is, or what data creating and editing might do, or what data management can be, doesn't live within one program. It doesn't live within one software. We have to use a software. We have to choose one to learn and teach from. I'm very comfortable with teaching from Arc. But everything you've learned is deployable elsewhere. And what I recommend to everyone who is learning GIS is to learn more than one GIS. You have to start somewhere, and it's probably not a good idea to learn on two at the same time. Learn one, feel good about one. Learn one, feel good about how you are comfortable with it, how it operates, where the buttons are, what the quirks are, what the operations are. Then learn more. In other work, I do research on GIS and geography education. And always remember, a quote from a faculty member I was interviewing about GIS and programming education, GIS and learning programming languages, learning computer science components, so on and so forth. And they said, when students ask me which programming language to learn, I say I can't tell them. But if they were to ask me which two programming languages to learn, I'd say one should be Python. And if they were to ask me which three they should learn, I would say two should be Python and JavaScript. And you could imagine so on and so on, some hierarchy in there. Learn a GIS. Learn the software. Learn how it operates. Then learn another one. And there are great other ones out there. They are different, of course, in their interface, their operating systems, their calculations, their capabilities. And those are things that can be stressed over and dealt with and worked with over time. The spatial components, thinking about cartography, geographic questions, the fundamentals of GIS are all the same. So let's consider a couple of open source places you might be doing your GIS next, or maybe you're doing it there now. Awesome. Learn another GIS. Very popular one is GRASS. GRASS was developed by the Army Corps of Engineers. You do a search on the YouTube for GRASS GIS video, you'll see who's there. GRASS, lots of good functionality, lots of good data handling, strong open source community. Same with QGIS. OSGeo, the Open Source Geospatial Foundation, also I don't know if manages is the right word, but QGIS and GRASS are both related to Open Source Geospatial Foundation. GRASS and QGIS are really the big players in the open source GIS space. And QGIS makes the most beautiful maps. Well, I mean, the cartographer makes the most beautiful maps, but I've always felt that the cartographer is most enabled to make beautiful maps in QGIS. Saga is another one to look at. Saga is great, especially if you have system concerns. If you want to run a GIS on a system that is perhaps not, the ultimate gaming machine, run it on Saga. Now, one of the other pieces in GIS that I think has to be mentioned is Python. Python is the programming language that underlies a lot of GIS operations. If you want to script or automate or run from code your GIS components, you want Python. In fact, your first thing that you should learn in Python is that little print statement right there. Something important to note in the GIS space is that many GIS jobs or analytical positions or workflows or whatnot do require some kind of programming knowledge and familiarity and understanding. It is not a bad thing at all to become familiar with some Python to help out your GIS learning. That being said, Python's a lot of fun to learn. And there are tons of great resources out there, open, accessible. You can do them on your own time and pace that make it easier to learn. So no one is GIS beyond. Is programming beyond either of those. Meant to be a little bit more inspirational when I get the order of words right. Programming isn't beyond anybody. GIS isn't beyond anybody. Programming is for everyone, just like GIS is for everyone. Visit the Hour of CI site to see plenty of examples of K-12 programming learning. Blow your mind. It's not magic. It is named after Monty Python's Flying Circus, though. I'm sure this isn't it. It does feel a little weird to end a lecture here on a programming language. But perhaps that's the best GIS lesson of all, is that you never know where it will take you. And it certainly won't ever end. Love to keep seeing your questions, your thoughts. Keep making walkthroughs. Until then, good one.